Hello and welcome to another session with Data Engineering Q&A. In today's session, we're going to talk about Spark cluster configurations. Now, this is one of the most important segment when it comes to clearing interviews because in real-world projects, these concepts help to make our Spark jobs run faster and more efficiently. So as usual, I'm going to start off with my brief introduction. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. Now, in the last session, we did talk about how to submit a Spark job in a cluster, and we also discussed the different deployment modes, such as client and the cluster, and how they are different from each other. Now, in today's session, we're going to talk about some extra parameters that even though those are optional, that we may or may not pass, but these are very crucial when it comes to utilizing the cluster resources properly and also fine tuning our Spark job. So as you can see, this Spark submit command is a bit more enhanced one. It has a bit more parameters or configurations compared to the one which I showed you in the last session. Okay, so apart from the Spark submit command and the master, which is obviously going to be yarn whenever we are running in a cluster, or probably it is local if we're just running in our own machine. But apart from that, there are other configurations or other parameters we are passing, such as the conf, which is having a key value pair. Okay, then there's the driver memory, executor cores, num executors. So what are these parameters and how do they affect in making the Spark jobs run faster and more efficiently? So we'll try to understand a bit about them. So first of all, we all know about the master yarn, which I've already discussed. Then the deploy mode, the cluster or the client. This one I've already covered in the last session. So let's start talking from this one, the third parameter. Okay, so third is nothing but hyphen hyphen conf. So this hyphen hyphen conf will take any sort of configurations, and configurations as in we have to pass a key value pair such as what kind of configuration I want my Spark job to handle based upon it could be shuffle partitions, it could be parallelism, it could be anything else. Okay, so over here I'm trying to pass a configuration to handle the shuffle partitions as 40. Now, when I was covering the shuffling in Spark, so I did mention that by default, whenever shuffling happens, whenever a new stage is created, so there will be 200 partitions created, right? And how they are created, because of the white transformations, data is moving across nodes, all of this has been discussed. So now what if I don't want to use the default 200? Okay, if I don't put anything in that case, by default 200 partitions will be created for every shuffle. So what if I want to tune down to 40 because I know based upon the data that I'm dealing with, I don't require 200 number of partitions. So I can eventually tweak that number. I can use 40, or if I know that probably I would need much more than 200, in that case I can put something like 400 or 300 for that matter. So the fact of the matter is that we pass a key value pair in the configuration where the key should be something like the Spark SQL shuffle partitions, and the value is after this equal sign, that is the 40 over here. Okay, so then comes the fourth parameter, that is the driver memory. So driver memory is the specified driver memory you can increase this when you collect in the large data. So what is driver memory? This has been also discussed in Spark architecture. So Spark has this master slave architecture sort of thing, which in which the driver is kind of like a master, which will initiate the Spark job in one of the nodes. If it is client mode, if it is being run in client mode, in that case, it will start the driver in the edge node where the client is sitting, and client being whoever is submitting the job. Or it could be in cluster mode where in one of the multi-node cluster setup, in one of the nodes, the driver will start off, and then the executors will start spawning in different other nodes. Okay, so that node over here, in that node, the how much memory my driver needs to run the job or to initiate the application, so that is known as the driver memory. So the amount of memory that I pass for the driver memory in that node where the driver is running, it will only take up that much amount of memory. Meaning, if suppose my driver is is getting initiated on a node A. Say for example, there is node A, B, C, D, and each and every node has say 16 gigabytes of memory, meaning RAM. So I'm assigning driver memory of 5G, meaning in node A, out of 16 gigabytes of RAM, only 5 gigabytes or 5 GB will be used up by the driver from that node. Okay, now coming to the fifth parameter, that is the executor memory. So accordingly, if I'm assigning some memory for my driver in all the other worker nodes where the executors are doing its own job, that is processing the tasks based upon the code that I've written in my Spark job. So obviously they would need some memory as well. So I have to allocate them some memory as well. So each and every node, say if they have 16 gigabytes of memory, okay, based upon my knowledge that the kind of cluster that I've set up, so in that case, I can also assign 8 gigabytes of memory. That is almost like half of the memory to each and every executor. Okay, so that is the executor memory, and you may be seeing that my executor memory is larger than the driver memory. Why is it so? So usually in the real world projects, I mean in everywhere, driver memory doesn't need to take up a lot of memory compared to the executor. The reason being, driver will simply spawn the executors, and drivers will only be come into action whenever I'm trying to accumulate the data. So there are some transformations and actions, right, in Spark. And whenever I call the actions such as collect or say count or try to show the data, so in all those cases driver memory will come into action. But in real world projects also, this is a true statement that we don't use such actions in our Spark code. What we do is we simply write the data into any HDFS or any cloud storage or probably in any Hive table or other database. So in those cases, the data will be written in partitions. So in that case, driver memory doesn't need to take up a lot of space. So main processing or the main executions are being carried out by the executor. So that is the main reason that executor memory needs to be allocated more than the driver memory. I mean, it's not like a hard and fast or thumb rule that the executor memory has to be more than driver memory, but usually, or I should say ideally, executor memory should have more storage or more spaces than the driver memory. Okay, so and why the executor memory is more important? I mean, why are we allocating more memory? So there are different segments as well. So in the next slide, when I'll be discussing the Spark memory management, so you'll get to know that why it is much more important than the driver memory. Right. Then coming to the executor cores. So this executor cores, meaning each and every executor, there will be n number of cores that they will be running. Okay, so the fact of the matter is executors will be running, that is part of the container, right? A container meaning a node that can have say 8 cores and 16 gigabytes of RAM, and not necessarily that one executor will take up the whole thing. Okay, so one executor, yeah, take up the whole thing. At the same time, it's not like that I have say 8 cores, so that means 8 executors have to run in the container. No, that's not the case. I can have one executor with say n number of cores. So suppose I can have one executor having all the cores in the node, or I can have say one executor having one core at the node. But that none of these options are quite uh, it's recommended or quite feasible when it comes to executing the Spark job. So it is kind of like a moderate based rule that keeping 4 to 5 virtual cores in each and every executor is a good practice. Okay, so that is why I have kept that as 4. And then the last one is the number of executors. So how many executors do I need? So basically, number of executors will be I have to think about how many nodes there are running. Okay, usually in all the projects that I've seen, it's more than 100 nodes that are usually running. But I mean, the number of I mean, if I increase the number of executors, in that case, there's a chance of getting higher parallelism for my Spark job, because see, executors will be running simultaneously. Each and every executor will run parallelly. So if my Spark job is, if I'm giving say in number of executors, in that case it will have in rank of parallelism. What I mean to say is that if I have 10 executors running, that means my data is segmented and being processed by 10 different executors or 10 different processes. Okay, So if I lower it down, if I put it 5, in that case, my job will take a bit more time because the parallelism is less. Now, the fact of the matter is, number of executor is 4, and each and every executor I am assigning 4 V cores or 4 virtual cores, which is the CPU cores. So in that case, total CPU cores or total V cores that are available for me at the time of running the Spark job is 4 into 4, that is 16. Okay, so just I'm gonna iterate this again. So number of executors. So before this, I have executor cores 4, meaning for each and every executor there will be 4 CPU cores. Okay. Now I'm assigning total number of executor is 4, meaning there will be total 4 executor, and each and every executor there are 4 number of CPU cores. So 4 into 4. So in my cluster, I am assigning 16 CPU cores to be alive at the time when I'm running the job. So this means, and as I have already mentioned, like each and every CPU core will take up one task or one partition. Okay. So if I have say 1 gigabytes of data, and it is being chunked in a way that it is creating say 90 or say 80 partitions. In that case, first 16, 4 into 4, 16, which are available, will take up the 16 partitions or 16 tasks. Rest 80 minus 16, that is around 64 if I'm not wrong. Those 64 will be in queue. Okay, so once the first 16 batch is done and completed, then the second 16 will come up. And total, if my math is correct, in that 16 into 5 is 80, right? So total, after 5 iterations, my Spark job should be completed. So that's how the Spark job runs in batches based on the iterations or the based on the parallelism. I mean, the number of partitions are getting created, and also the number of resources or the number of executors that I'm allocating at the time of running the Spark job. So that's how it kind of runs in the cluster. Okay, so I know some of the things may be going over the head, but just try to understand that how do we achieve the parallelism, and it should be a moderate level. It's not like that I know that I have 100 nodes that I should have 100 executors, right? Because the cluster, in the cluster, it's not like I'll be the only one who's submitting the Spark jobs and I'm the only one who's using the cluster. It's gonna be a shared cluster, right? A lot of people or a lot of other applications will be running their job, so I cannot simply hog all the cluster resources because I have the availability. Okay, so these are the things I have to keep in mind, that I should utilize the cluster resources in a to a level or to an extent where my job is running efficiently without any sort of issue. Also, at the same time, other applications are being run simultaneously. They don't have any issue as well. So so this is the reason why this concept is very important for us to have a in-depth knowledge. And in every interview I've faced, I've also asked the candidates every interview to just explain me the extra cluster resources or the set of configuration that we pass on while submitting the Spark job. So what is the significance of those driver memory, executor cores, and how do they actually impact the Spark job that I'm submitting in my cluster? Okay. Now let's talk about the second part, which is the memory management. Now I told you, right, that executive memory, I'm always allocating a bit more than the driver memory because there are a lot of things happening, and executor memory is not being used by only execution, but there are different things as well. So let's take a look at that. Okay. So first of all, if I talk about the memory in my node, so there are two kinds of memory. One is the on-heap memory, the other one is the off-heap memory. Okay, so off-heap memory is something that is being used for other daemons to run, or probably some extra data structure or some raw Python or raw Java code to run. So those are the reasons the off-heap memory should be there. And sometimes the due to out of memory execution in the off-heap memory, we may need to tweak that as well. So there is a different configuration for that, and we have to put it in a key value pair, which I just showed in the last slide. Okay, so if I talk about the on-heap memory, so there are three segments. One is the reserved memory. So this is basically is always gonna be kept as a backup and something like a bench, 300 memory or something like some very small percentage of it. Okay, so this has to be freed memory. Okay, we won't be using this much. Second one is the user memory. So what is user memory? It is being used for user defined data structures, UDFs or internal metadata, or some, if I'm using the RDD, in that case RDD conversion operations or RDD lineage and conversion, all these things. So in my Spark job, I have not shown UDF till now, but yes, I will be discussed in one of the later sessions. What is UDF? It is nothing but a customized user function which is not using any of the Spark SQL function, or it's kind of like a raw Python code that I can accommodate into my PySpark job. So those cases, and also if I have some user defined data structure, say suppose I'm using a list or a dictionary or a tuple for that matter, so those will be stored in the user memory. Okay, then comes the execution memory or the executor memory. Okay, I mean the processor memory. So over there, there is a memory fraction, or there is also a segmentation of in the same place. One you can see is being used for storage. The other one is for the executor memory. Okay, now the fact of the matter is, whatever memory that I provide for the executor, that is, if I'm providing 8 GB, this 8 GB will be taken up whole. Okay, so this part is the 8 GB. Now, in this 8 GB, there will be certain section which will be used for storage, and that is simply for either caching or persisting. Okay, I did mention about caching and persisting to store the intermediate data frame. When I'm using same data frame over and over again, I can simply use it or persist it into the memory. So this is where that cached or the persisted data frame resides. Okay, and this takes almost 60%. So by default it is 60%, but not necessarily that it will like 60% is reserved for it. Okay, if my execution takes a bit more space, in that case it will simply push it up and make it say 50% or 55% or even less than that. Okay, and simply the fact is, if I'm persisting or caching data, it also needs to be taken into mind that or taken into action that that space is available over here. So suppose out of 8 GB, only 3 GB is specified for here and 5 GB for execution. Okay, so but my persistent data frame itself is say 4 GB, then what will happen? Then it will simply spill into disk, because there is an extra 2 GB over there, right? So that's how it works. And REST execution is I mean something that I mean something that is being used by the Spark job itself. So I'm writing the transformations such as the join or the filter map, or selecting some columns. So whatever aggregation, everything, all the task or all the processing that I'm writing in my Spark job, so those will be taken up by the executor memory. Even though this is known as the executor memory, but when I'm assigning the executor memory tag in my Spark submit parameter, so I'm basically allocating the memory to this whole segment, not only this one. Okay, so this is a very important thing to understand, and so this is the reason that we have to allocate some more memory for the executors, because I have to also take the caching or the persisting into account, that it may take up a bit of memory whenever I'm trying to put the intermediate data frame into some storage. And also the execution, if there's some shuffling or some other heavy operations are going on, in that case 200 partitions will be created, so each and every partition will take up some memory, right? So due to these factors, executors memories are given a bit more precedence than the driver memory. Okay, so this is all about the Spark memory management and also about the cluster configurations. And this is, as I have mentioned quite a couple of times, that it's one of the most very important segment to crack the interviews. Having a clear idea about how the memory management works, how to assign the proper the number of executors, or the memory for the driver and the executor is very important for us to not only to clear the interviews. Even if you clear the interviews, you will be working upon on real projects, and over there you will be encountering these sort of scenarios. So that's all from this session, folks. Do reach out to us if you need any help. We do cover all the necessary tools in our course, such as the Spark, Hadoop, Hive, AWS, with hands-on coding and real-world project. We also assist in getting job as early as possible. We will create an interview-ready profile for you. We will conduct mock interviews, and we will make sure that you're up for the you're up for cracking any data engineering interviews that may come forward. So I'm signing off from this session. See you on the next session. Bye bye, everyone.
Contact us for the free job assistance. We will help you to get the IT job Please like, subscribe, and share the channel for more regular updates from TechSpark.